The morning air on planet Kepler 442b felt thick and strange against Jake Miller's skin as he walked toward the massive glass building that housed the Galactic Engineering Academy. 3 suns hung in the purple sky above him, casting weird shadows that moved in different directions at once. Jake had been on this planet for 6 months now, but he still wasn't used to the way everything looked so alien and beautiful at the same time. Jake was the only human student at the academy. Most days, this made him feel special and proud. Other days, like today, it made him feel very alone. He pushed through the heavy doors and made his way to Classroom 7 Alpha, where his advanced survival engineering class was about to begin. The classroom was huge, designed to fit students from dozens of different alien species. Jake took his usual seat in the middle section, designed for humanoid beings about his size. Around him, his classmates were settling into their own specially designed seats and desks. To his left sat Velnox, an Altarian who looked like a tall, thin person made of silver metal. Velnox's head was perfectly round with no nose or mouth, just 2 glowing blue circles where eyes should be. The Altarian communicated through a small device attached to his chest that turned his thoughts into words that everyone could understand. Behind, Jake sat Zack, a student from the Kethri species. Zack looked like a giant grasshopper that could walk on 2 legs. His 4 arms moved constantly as he worked on calculations, and his large black eyes never seemed to blink. Zack was probably the smartest student in their class when it came to pure mathematics. Near the front of the room, Reef was adjusting her water tank suit. She was an Aquarian, which meant she needed to stay wet to survive. Her blue-green skin had tiny scales that sparkled under the classroom lights, and she had gills on the sides of her neck that opened and closed slowly. When she spoke, her voice sounded like water running over smooth stones. Nixta sat in a special chair that looked like a metal tree with 6 branches. She was a hexapod, which meant she had 6 arms that could move in ways that made Jake's head hurt just watching. Each of her arms ended in a hand with 12 fingers, and she could write 6 different equations at the same time without making a mistake. In the back corner, Gronwell took up an entire section by himself. He was a Terran type, which meant he was basically a walking mountain of gray rock with glowing orange eyes. When Gronwell thought really hard about something, small sparks would fly from the cracks in his stone skin. He was incredibly strong, but thought very slowly compared to the other students. The strangest student in their class was Kiral, who wasn't really solid at all. Kiral was a gaseous being who usually looked like a cloud of purple and gold mist, floating in the air. Sometimes he would make himself more solid so he could hold things or write on paper, but most of the time he just drifted around like smoke. Professor Zithkar entered the room, and all conversation stopped immediately. The professor was a Vextai, which meant he looked like a walking crystal sculpture that was twice as tall as Jake. His body was made of some kind of clear blue crystal that caught the light and threw rainbow patterns on the walls. When he spoke, his voice sounded like wind chimes in a gentle breeze. "Students," Professor Zithkar began, "today marks the beginning of your final survival engineering examination." The crystal professor moved to the center of the room, and Jake could see tiny lights flickering inside his transparent body. "You will be transported to our wilderness training facility, where you will face a challenge that has tested engineering students for over 300 years. Jake felt his heart start beating faster. He had heard stories about the final exam from older students. Some said it was impossible. Others said it was designed to make students work together and think creatively. A few students whispered that some test takers had never returned, though Jake was pretty sure those were just scary stories meant to frighten new students. "The challenge is simple to understand but difficult to solve," the professor continued. "You must cross the Crimson Ravine using only materials you can find in the surrounding forest and the basic tools in your survival packs. The ravine is 200 meters wide and 100 meters deep. The walls are too steep to climb down and too smooth to use climbing equipment. Velnox's chest device hummed to life. Professor, what materials are available in the forest? Can we assume standard carbon-based plant life with typical molecular structures? You will discover what materials are available when you arrive, Professor Zithkar replied. That is part of the challenge. Zack raised one of his forearms. How much time do we have to complete this crossing? 72 hours from the moment you arrive at the site, the professor answered. You may work alone or in groups as you choose. However, every student must successfully cross the ravine to pass the examination. Jake looked around the room as his classmates immediately began forming groups and discussing strategies. Reef was already talking to Nixta about fluid dynamics and water displacement. Velnox had pulled out a small computer and was running calculations about bridge construction and weight distribution. Zack was drawing diagrams on his desk, showing complex pulley systems and mechanical advantage formulas. His forearms moved so fast that Jake could barely follow what he was writing. Gronwell had moved closer to the others, listening carefully to their ideas, with his glowing orange eyes focused intently on their work. Only Kiral seemed as quiet as Jake. The gaseous being floated near the window, his purple and gold mist swirling slowly as he looked out at the alien landscape. Transportation to the test site will begin in 1 hour, Professor Zithkar announced. Use this time to gather your thoughts and prepare your survival packs. Remember, you may only bring basic tools, no advanced technology, no computer assistance, and no communication devices. You must rely on your knowledge, your creativity, and your ability to work with the natural materials you find. As the professor left the room, the noise level immediately increased. Students were calling out ideas, arguing about the best approaches, and trying to form the perfect teams. Jake sat quietly in his chair, thinking about the challenge ahead. 200 meters was a long way. Jake tried to picture it in his head by thinking about football fields back on Earth. It would be like crossing from one end zone to the other end zone of 2 football fields placed end to end. And with a 100-meter drop below, there would be no room for mistakes. Jake had always been good with his hands. Back on Earth, he had spent summers working with his grandfather, who was a carpenter. They had built tree houses, repaired old barns, and even constructed a small bridge over the creek that ran through his grandfather's property. But those projects had used modern tools and materials bought from hardware stores. This challenge would be completely different. While his classmates continued their intense discussions about mathematical models and engineering principles, Jake found himself thinking about simpler things. What kind of trees grew in alien forests? How strong were the vines and plants on this planet? What did the landscape around the ravine actually look like? He realized that while everyone else was trying to solve the problem before they had even seen it, he was more curious about understanding what they would actually be working with. Maybe that was a human thing, or maybe it was just the way his grandfather had taught him to approach problems. First, you look at what you have to work with. Then you figure out what you can build. The transport ship landed on a flat area of red dirt surrounded by the strangest forest Jake had ever seen. The trees were tall and thin with silver bark that seemed to shimmer in the light of the 3 suns. Their leaves were deep purple and moved in the wind like they were made of silk. Between the trees, thick green vines hung down like natural ropes, and strange blue flowers bloomed on bushes that grew as tall as Jake's shoulders. The crimson ravine stretched out in front of them, like a giant wound in the earth. The walls were smooth red rock that dropped straight down into darkness. Jake could hear water running somewhere far below, but he couldn't see the bottom even when he lay on his stomach and looked over the edge. The ravine was exactly as wide as Professor Zithkar had said, but seeing it in person made it seem much more impossible to cross. On the other side of the ravine, Jake could see more of the silver-barked trees and purple-leafed forest. It looked exactly like the side they were on, which meant there would be the same materials to work with on both sides. That was good information to have. Jake's classmates immediately set up a base camp about 50 meters back from the ravine's edge. They arranged their sleeping bags and supplies in a neat circle and began pulling out notebooks, measuring tools, and portable computers. Even though Professor Zithkar had said no advanced technology, the simple computers they carried were considered basic tools by galactic standards. Velnox was the first to start making detailed calculations. His metal fingers moved across his computer screen with incredible precision, and numbers and diagrams appeared in the air above the device as three-dimensional holograms. Based on the width of the ravine and estimated wind conditions, a suspension bridge would require cables with a tensile strength of at least 40,000 pounds per square inch, he announced to the group. Zach looked up from his own calculations. A suspension bridge would be inefficient given our available materials, he said in his clicking, insect-like voice. I propose a cantilever design using logarithmic weight distribution. We could build supporting structures on both sides and extend them toward the center until they meet. Reef had filled several containers with water from a small stream that ran near their campsite. She was testing the water's pH levels and mineral content using a small kit from her survival pack. Both of your approaches ignore the fundamental engineering principles of this environment, she said in her musical, flowing voice. We should redirect the underground water source to partially fill the ravine, then build a series of stepping stones across the reduced gap. Nixta had been quiet during the others' presentations, but now all 6 of her arms were moving at once. She was writing equations on 6 different pieces of paper simultaneously, and each equation seemed to be solving a different part of the bridge problem. Suspension bridge calculations are incomplete without proper analysis of dynamic load factors, she said without looking up from her work. Wind resistance, material fatigue, and harmonic oscillation must all be considered in the primary structural equations. Gronwell sat on a large rock near the group, listening carefully to everything his classmates said. Small sparks flew from the cracks in his stone skin as his slow but powerful mind processed all the information. All your bridges need strong foundations, he said in his deep, rumbling voice. I can provide the strength to build whatever foundation structures you design, but someone must tell me exactly where to place each stone and how to arrange each support beam. Kiral drifted between the other students like a cloud of purple, smoke, occasionally solidifying enough to look at their calculations and diagrams. Your approaches all assume that solid construction is the only solution, he said in a voice that sounded like wind through hollow reeds. Perhaps we should consider less conventional methods. I could carry materials across the ravine in my gaseous form, or we could develop a chemical solution that would allow temporary matter transportation. Jake sat a little apart from the main group, sketching in his notebook and listening to the discussion. His classmates were incredibly smart, and their ideas were amazingly complex. Velnox's suspension bridge calculations filled 3 pages, with mathematical formulas that Jake couldn't even begin to understand. Zach's cantilever design involved precise angles and weight distributions that would require computer-controlled construction to get right. But as Jake listened to the increasingly heated debate between his classmates, he noticed something important. They were all trying to solve the problem using the most advanced techniques they knew, but none of them had actually walked around the area to see what materials were really available. While Velnox argued with Zach about the relative merits of suspension versus cantilever bridge designs, Jake got up and walked into the forest. The silver-barked trees were smooth and straight, and when Jake knocked on them with his fist, they sounded solid and strong. The vines hanging between the trees were as thick as his arm in some places, and when he pulled on them, they felt sturdy and flexible. Jake found several trees that had fallen during recent storms. The wood was weathered but still solid, and the trees were long enough to be useful for construction. Near the stream, he discovered a patch of the blue flowering bushes that had stems as straight and strong as bamboo back on Earth. By the time Jake returned to the camp, his classmates had been arguing for 4 hours about which bridge design was theoretically superior. Reef had drawn detailed diagrams showing how to divert the underground stream. Nixta had covered 12 sheets of paper with mathematical proofs about optimal bridge construction. Zach had calculated the exact angles needed for a cantilever bridge, and Velnox had determined the precise cable thickness required for a suspension bridge. "What do you think, Jake?" Reef asked when she noticed him returning from the forest. "Which approach seems most practical to you?" Jake looked at all the diagrams and calculations spread out around the campsite. His classmates had spent hours developing incredibly sophisticated solutions to the bridge problem. Each design was mathematically perfect and scientifically sound, but Jake couldn't help thinking about his grandfather's old workshop motto that hung on the wall back home. "Keep it simple, stupid." "I think all of your ideas are really smart," Jake said carefully. "But maybe we should start by figuring out exactly what materials we have to work with. I've been looking around the forest, and there are some interesting possibilities out there." Velnox's glowing blue eye circles focused on Jake. "What materials did you observe? Can you provide specifications for tensile strength, flexibility coefficients, and structural durability?" Jake pulled out his notebook and showed his simple sketches of trees, vines, and fallen logs, compared to the complex technical diagrams his classmates had created. His drawings looked like something a child might make. "I don't have exact measurements," he admitted, "but the trees seem strong, the vines are really thick and flexible, and there are some fallen logs that might be useful." Zach's 4 arms stopped moving, and he looked at Jake's sketches with his large black eyes. "These observations are too imprecise for proper engineering calculations," he said. "We need exact measurements, stress analysis, and material composition. Data before we can proceed with any construction." "Zach is correct," Nixta agreed. "Proper engineering requires complete data analysis before beginning any physical construction." Jake nodded and put his notebook away. His classmates were right, of course. Their approach was scientific and careful, and exactly what they had been taught at the academy. But as the first day ended and his classmates were still debating the finer points of bridge engineering theory, Jake found himself thinking more and more about those strong vines and sturdy trees he had seen in the forest. The 3 moons of Kepler 442b cast strange silver light through the purple leaves as Jake quietly slipped out of his sleeping bag. His classmates were still awake around their small campfire, arguing about mathematical formulas and engineering principles. Velnox was projecting holographic diagrams into the air while Zach drew increasingly complex calculations on a portable whiteboard. Reef and Nixta were debating the structural properties of different bridge designs, and even Gronwell had contributed some ideas about foundation construction. Jake had listened to their discussions for hours, and he had to admit that their ideas were brilliant. Each of his classmates understood engineering principles that Jake had never even heard of. They could calculate stress loads and material fatigue and wind resistance with mathematical precision that amazed him. But as the hours passed, Jake noticed that they were spending more and more time arguing about tiny details and less time actually working on solutions. While his classmates continued their debate, Jake picked up his basic toolkit and walked quietly toward the forest. The alien trees looked different in the moonlight, their silver bark glowing softly like metal that had been polished to a mirror shine. The thick vines hanging between the trees swayed gently in the night breeze, and Jake could hear the sound of the stream running somewhere in the darkness. Jake had spent the day thinking about the bridge problem, but not in the same way his classmates had approached it. Instead of starting with complex engineering theories, he had been thinking about the bridges he had built with his grandfather back on Earth. They had never used complicated calculations or computer models. They had simply looked at what materials they had available and figured out the simplest way to get from one side to the other. The bridge over his grandfather's creek had been a simple rope bridge. They had used strong rope from the hardware store, some wooden planks for the walking surface, and trees on both sides for anchor points. It hadn't been fancy or mathematically perfect, but it had worked perfectly for its purpose. Jake started by testing the vines more carefully than he had during his earlier exploration. He found a vine as thick as his wrist and pulled on it with all his strength. The vine stretched slightly but held firm. He wrapped it around a sturdy tree trunk and hung his full weight from it. Still solid. He found a sharp rock and cut through a section of the vine. The interior was made of tough fibers that looked like they would be perfect for rope making. Working by moonlight, Jake began the slow process of gathering materials. He cut down dozens of the thick vines, testing each one to make sure it was strong enough for his purpose. He found a fallen tree trunk that was straight and about 10 meters long. The wood was hard and had been weathered smooth by wind and rain, but it was still structurally sound. Jake had learned rope making from his grandfather, who had learned it from his grandfather, who had been a sailor in the old days. It was one of those practical skills that got passed down through families, even when nobody really needed it anymore. Now, on an alien planet millions of miles from Earth, Jake was grateful for every knot his grandfather had taught him. He started by stripping the outer bark from the vines to get to the strong fibers underneath. Then he began the process of twisting and braiding the fibers together to make rope. It was slow, careful work that required constant attention to keep the tension even and the weave tight. One weak spot in the rope could mean disaster when someone tried to cross the ravine. As Jake worked, he could hear his classmates still talking around their campfire. Occasionally, one of them would call out a question or make an excited announcement about some new calculation they had completed. Jake smiled to himself as he worked. They were still trying to solve the problem with their minds, while he was trying to solve it with his hands. By the time the first of the three suns began to rise, Jake had braided enough rope to reach across the ravine twice. He tested each section by tying it between two trees and hanging his full weight plus rocks from his survival pack. The rope held without any signs of strain or weakness. Next, Jake needed to find the right trees to use as anchor points. On his side of the ravine, there was a massive silver-barked tree about 20 meters back from the edge. The tree was easily 2 meters across at the base and looked like it had been growing there for hundreds of years. Jake tested it by tying his rope around the trunk and pulling as hard as he could. The tree didn't budge. The problem was the tree on the other side of the ravine. Jake could see several large trees that would work perfectly as anchor points, but he needed to get his rope across the 200-meter gap first. Jake had been thinking about this problem while he worked on the rope. His classmates would probably solve it with some kind of launching device or projectile system based on physics calculations. But Jake had a simpler idea that he had learned from watching his grandfather repair telephone lines. He found a straight branch about 2 meters long and as thick as his thumb. Then he selected his lightest but strongest piece of rope, about 50 meters long. He tied one end of the rope to a small rock and the other end to the branch. Using the branch like a fishing rod, Jake began casting the rock across the ravine. It took 17 tries before the rock finally made it all the way across and landed in the forest on the other side. Jake felt a thrill of success as he carefully pulled the rope tight and felt the resistance that meant his rock had gotten tangled in the trees on the far side. Now came the hard part. Jake tied his main rope to the light rope and began the slow process of pulling it across the ravine. He had to be incredibly careful not to let the heavy rope snag on the rocks at the edge of the ravine or put too much strain on his light guide rope. It took almost 2 hours, but finally Jake had his main rope stretched across the ravine with both ends secured to strong trees. He tested the setup by attaching his heaviest rocks to the rope and bouncing them up and down. The rope held steady with no signs of stretching or weakness, but a single rope wouldn't be safe enough for people to cross on. Jake needed to build a proper bridge with handholds and a walking surface. He spent the rest of the morning creating 2 more ropes and getting them across the ravine using the same technique he had used for the first one. By the time his classmates started waking up and preparing breakfast, Jake had 3 strong ropes stretched across the ravine. One rope was positioned low to serve as the walking surface, and 2 ropes were positioned higher on either side to serve as handholds. Jake was exhausted from working all night, and his hands were covered with cuts and scrapes from handling the rough vines. His clothes were dirty and torn, and he had plant sap in his hair from crawling through the forest looking for the best materials. But as he looked at his bridge taking shape across the ravine, he felt the same sense of satisfaction he used to feel when he and his grandfather finished a project together. The bridge wasn't pretty by galactic engineering standards. It swayed in the wind and looked primitive compared to the elegant suspension bridges and cantilever designs his classmates had been calculating. But it was real, and it was almost finished, and Jake was pretty sure it would work. The sound of voices growing louder woke Jake from the short nap he had taken after finishing his bridge. He had worked through the entire night and most of the morning, and his body ached from the physical labor of cutting vines, braiding rope, and hauling materials back and forth across the forest. But as he opened his eyes and saw the 3 ropes of his bridge stretching across the crimson ravine, he felt a deep sense of accomplishment. Jake could hear his classmates moving around the campsite, probably getting ready to start another day of calculations and theoretical planning. He stretched his sore muscles and walked over to check his bridge one final time before the others discovered what he had built. The walking rope was stretched tight and secure between the 2 anchor trees. Jake had woven smaller vines around it to create a more stable surface for people to stand on. The 2 handrail ropes were positioned at exactly the right height for someone of his size to hold on to while crossing. Jake had tested every knot and every connection point multiple times during the night. Now came the real test. Jake took a deep breath and stepped onto his bridge. The rope surface swayed slightly under his weight, just as he had expected. Jake gripped the handrail ropes firmly and took another step forward. The bridge held steady. He took another step, then another. Within a few minutes, Jake was standing in the middle of the ravine, 200 meters above the rocky bottom, supported entirely by the bridge he had built with his own hands. The view from the center of the bridge was incredible. Jake could see for kilometers in every direction across the purple-leafed forest. The 3 suns of Kepler 442b painted everything in shades of gold and silver, and strange flying creatures that looked like tiny dragons soared through the air far below him. But the best part was that the bridge worked exactly as Jake had hoped it would. It was strong enough to support his weight easily, stable enough that he didn't feel like he was going to fall, and simple enough that anyone should be able to cross it safely. Jake made his way across to the far side of the ravine and spent a few minutes checking the anchor points on that side. Everything looked good. Then he crossed back to rejoin his classmates, feeling proud and tired and ready to show them what he had accomplished. The reaction when his classmates discovered the bridge was not exactly what Jake had expected. Velnox was the first to notice. The Altarian had been walking toward the ravine edge to take some measurements when he stopped suddenly and stared at the 3 ropes stretching across the gap. His glowing blue eye circles flickered rapidly, which Jake had learned meant he was thinking very fast. "This is impossible," Velnox announced through his chest communication device. "According to my calculations, rope bridges require specific tensile strength ratios and load distribution factors that cannot be achieved with natural materials." Zach came running over with all 4 of his arms waving excitedly. "Who built this?" he demanded in his clicking voice. "The construction violates several fundamental engineering principles. The weight-to-strength ratio is completely wrong, and there are no proper load-bearing supports." Reef flowed over to examine the bridge, her blue-green scales shimmering with curiosity. "The design is remarkably primitive," she said in her musical voice, "but it appears to be functional despite its lack of mathematical precision." Nixta had pulled out measuring tools and was examining the bridge construction with all 6 of her arms working at once. "The rope diameter is inconsistent," she announced. "The weaving pattern shows no consideration for stress distribution. The anchor points are positioned incorrectly according to standard suspension engineering. This should not work. Gronwell approached the bridge slowly, his massive stone feet making the ground shake slightly with each step. He examined Jake's anchor points carefully, running his rocky fingers over the knots and rope connections. "The construction is crude but solid," he rumbled. "The human has done good work with simple tools." That was when everyone turned to look at Jake. He was sitting on a fallen log near the bridge, still tired from his night of work, but smiling at his classmates' reactions. "You built this?" Reef asked, her voice rising with surprise. "During the night? By yourself? You didn't use any calculations or engineering software?" Velnox demanded. "How did you determine the proper load specifications?" Jake shrugged. "I just used what I learned from my grandfather. He taught me how to make rope and tie knots and build simple bridges. I tested everything to make sure it was strong enough, and then I put it together." Zach's forearms were moving frantically as he tried to calculate the engineering specifications of Jake's bridge. "This is not possible," he muttered. "The mathematics do not support the observed structural integrity." "Maybe we should test it," Jake suggested. He stood up and walked over to his bridge. Without hesitation, he stepped onto the walking rope and began crossing the ravine again, just as he had done an hour earlier. His classmates watched in amazement as Jake made his way across the swaying bridge. He moved confidently and steadily, clearly comfortable with the construction. When he reached the other side, he waved back at them and then crossed back again. "The bridge supports his weight without any signs of structural failure," Nixta observed, still running calculations on her portable computer. "But according to my analysis, it should have collapsed immediately." "Your analysis might be wrong," Gronwell said quietly. The big stone being walked over to the bridge and examined it more closely. "Sometimes the simple approach works better than the complicated one." "Would you like to try crossing?" Jake asked Reef. "The rope might feel a little bouncy at first, but it's really quite stable once you get used to it." Reef looked nervous, but she stepped onto the bridge carefully. The rope swayed under her different weight distribution, but it held firm. She made her way across slowly, gripping the handrail ropes tightly. When she reached the other side safely, she called back to the others with excitement in her voice. "It works perfectly. The human bridge is completely functional." One by one, Jake's classmates tested his bridge. Velnox crossed with mechanical precision, calculating angles and forces with every step. Zach scuttled across quickly on his four legs, muttering about impossible engineering the entire way. Even Nixta managed the crossing, though she needed to use all 6 arms to maintain her balance. The real test came when Gronwell decided to try crossing, the massive stone being weighed at least 3 times as much as any of the other students, and everyone watched nervously as he stepped onto Jake's bridge. The rope stretched and groaned under Gronwell's weight, but it held. Jake had built his bridge strong enough to handle much more weight than any of his classmates, and even Gronwell's massive bulk wasn't enough to break the thick braided ropes. When Gronwell reached the other side safely, the other students broke into surprised cheers and congratulations. Even Kirol, who had been floating around the bridge in his gaseous form, solidified enough to speak. "The human has accomplished in one night what we have been debating for 2 days," he said in his wind-like voice. "Perhaps there is wisdom in simplicity that our complex calculations cannot capture." As Jake's classmates celebrated his successful bridge, he felt a mixture of pride and confusion. He was happy that his bridge worked and that his friends were impressed, but he didn't really understand why they found it so surprising. To Jake, building a rope bridge had seemed like the obvious solution to crossing a ravine. It was the same approach humans had been using for thousands of years in similar situations. But looking at his classmates' advanced computers and complex mathematical models, Jake began to realize that maybe the human approach to engineering problems was different from what other species considered normal. Maybe sometimes the simplest solution really was the best one, even if it didn't look impressive on paper. 1 week after returning from the wilderness training facility, Jake walked into the largest lecture hall at the Galactic Engineering Academy. Word about his rope bridge had spread quickly through the school, and Professor Zithkar had announced a special presentation about alternative engineering methodologies that would be open to students from all departments. The massive hall was packed with beings from dozens of different species, all curious to hear about the human student who had solved the Crimson Ravine challenge in a way that none of their advanced computer models had predicted. Jake felt nervous as he took his seat in the front row next to his classmates from the survival engineering course. Velnox leaned over toward Jake, his glowing blue eye circles focused intently. "I have run the calculations for your bridge design 437 times since we returned," he said through his chest communication device. "According to every engineering simulation I can create, your bridge should have failed catastrophically, yet it clearly worked perfectly. This presents a significant problem for my understanding of structural engineering principles." On Jake's other side, Zach was rapidly sketching diagrams with all 4 of his arms. "I have been researching primitive construction techniques used by various species throughout galactic history," the insect-like being said in his clicking voice. "Your methodology appears to be based on empirical testing rather than theoretical calculation. This approach was abandoned by most advanced civilizations thousands of years ago." Reef flowed into the seat behind Jake, her water tank suit making soft splashing sounds as she settled in. "I have been thinking about your bridge every day since we returned," she said in her musical voice. "The design violated every principle of proper engineering that I have learned, but it accomplished exactly what we needed it to do. How did you know it would work without testing it with computer simulations?" Jake turned around to face Reef. "I did test it," he said. "I pulled on every piece of rope to make sure it was strong enough. I checked every knot to make sure it was tied correctly. I walked across it myself before anyone else tried it. That seemed like plenty of testing to me." "But you did not calculate load-bearing specifications or wind resistance factors or material fatigue coefficients," Nixta pointed out from her multi-armed chair. "How could you be certain the bridge would not fail during use?" "I couldn't be completely certain," Jake admitted. "But my grandfather always said that if you build something strong enough to hold twice the weight you need it to hold, and you test it carefully before you use it, then it will probably work fine. Most of the time, that approach has worked out pretty well." Professor Zithkar entered the lecture hall, and the conversations throughout the room immediately stopped. The tall crystal being moved to the center of the speaking area, and rainbow. Patterns of light danced across the walls as he positioned himself under the hall's illumination system. "Students," Professor Zithkar began, his wind chime voice carrying clearly throughout the large space. "Today we will examine a fascinating case study in engineering problem-solving. As many of you have heard, the recent survival engineering examination produced an unexpected result that challenges some of our fundamental assumptions about proper construction methodology." The professor gestured toward a large display screen that descended from the ceiling. Images of the Crimson Ravine appeared, showing the site before and after Jake's bridge construction. The audience murmured with interest as they saw the simple rope bridge stretching across the massive gap. Student Jake Miller accomplished this crossing using what most of you would consider primitive construction techniques, Professor Zithkar continued. "No computer calculations, no advanced materials analysis, no theoretical modeling. Yet his solution succeeded where more sophisticated approaches remained in the planning stages." A student from the advanced physics department raised one of her tentacles. "Professor, surely this was simply a case of luck rather than proper engineering methodology. The bridge could have failed at any moment during construction or use." "Professor," Zithkar's crystal body flickered with brighter internal lights. "An excellent question, Student Kexela. Jake, would you please explain your testing procedures to the audience?" Jake felt his heart beating faster as hundreds of alien eyes focused on him. He had never spoken to such a large group before, and he wasn't sure his simple explanations would make sense to students who were used to complex mathematical proofs. "Well," Jake began, his voice echoing strangely in the large hall. "I tested every piece of material before I used it. I would tie a vine between two trees and hang rocks from it to see how much weight it could hold. If a piece of rope could hold 3 times my weight plus extra rocks, then I figured it would be strong enough to use in the bridge." "But how did you calculate the safety margin without knowing the exact tensile strength of the materials?" called out a student from the materials science section. "I didn't calculate it exactly," Jake replied. "I just made sure everything was much stronger than it needed to be. My grandfather taught me that if you build something that can handle twice what you think you'll need, then you'll probably be okay even if you made some mistakes." A crystalline student near the back of the hall stood up. "Your methodology appears to lack scientific rigor. How can you ensure consistent results without mathematical verification of your assumptions?" Jake thought about this question for a moment. "I guess I can't ensure consistent results the same way you can with math. But humans have been building bridges like this for thousands of years, and the technique has worked pretty well most of the time. Sometimes experience can be just as valuable as calculations." Professor Zithkar moved closer to the center of the hall. Student Miller raises an important point about the relationship between theoretical knowledge and practical experience. Throughout galactic history, we have seen examples of species that developed highly sophisticated theoretical frameworks but struggled with practical implementation. The professor activated another display showing historical examples of engineering projects from various civilizations. The Vorthan Empire created mathematical models of incredible precision, but built structures that frequently failed because their calculations did not account for real-world variables. The Nexus Collective developed theoretical engineering that was mathematically perfect but required materials that did not exist in nature. "Are you suggesting that primitive construction methods are superior to advanced engineering?" asked a student from the Quantum Architecture program. "Not superior," Professor Zithkar replied, "but potentially complementary. Student Miller's approach demonstrates the value of empirical testing, iterative improvement, and working with available materials rather than requiring ideal conditions." Velnox activated his communication device. "Professor, I have analyzed Student Miller's bridge construction and found multiple violations of standard engineering protocols. The rope diameter varies significantly along its length. The anchor points are not positioned according to optimal load distribution calculations. The overall design shows no consideration for harmonic resonance or dynamic load factors." "All of your observations are correct, Student Velnox," Professor Zithkar agreed. "Yet the bridge functioned perfectly for its intended purpose. This suggests that our standard protocols, while mathematically sound, may not be the only valid approach to engineering challenges." Jake found himself thinking about his grandfather's workshop again. "My grandfather used to say that the best tool for any job is the one that gets the work done safely and efficiently. Sometimes that's the most advanced tool you can find, and sometimes it's the simplest one. The important thing is to use the right tool for the specific job you're trying to do." Gronwell's deep voice rumbled from the front row. "The human speaks wisdom. In my homeworld's mining operations, we have found that simple, robust solutions often outperform complex systems in harsh environments. Complicated equipment breaks down when conditions are difficult, but basic tools continue to function." Reef raised one of her scaled hands. "Professor, does this mean we should abandon mathematical engineering principles in favor of empirical construction methods?" "Absolutely not," Professor Zithkar replied immediately. "Mathematical engineering principles are essential for large-scale construction, precision manufacturing, and projects where failure could be catastrophic. But Student Miller's success demonstrates that we should also value practical problem-solving skills, hands-on experience, and the ability to work creatively with available resources." A student from the theoretical physics department called out from the upper levels of the hall. "How do we know when to use advanced calculations versus simple construction methods?" Jake was surprised when Professor Zithkar looked directly at him to answer this question. I think it depends on what you're trying to build and what resources you have available, Jake said. If you're building a spaceship or a nuclear reactor, then you definitely need precise calculations and advanced materials. But if you're trying to get across a ravine with some trees and vines, then maybe a simple rope bridge is the right answer.